This video covers the 2019 official AP practice exam, and it's going to be a short video. We're just covering number 5. And in number 5, you've got, just reading through it, says Brandon and Chloe ride their bikes for 4 hours along a flat straight road. Brandon's velocity is a differentiable function, and selected values are in this table. And then Chloe's velocity is this piecewise function. So you have one function from 0 to 2 and then another function from 2 to 4. All right, part A says, how many miles did Chloe travel from time t equals 0 to t equals 2? This one is not going to be on the 2020 test. The total miles, which we could call S of t, we would integrate, all right, from 0 to 2 of t e to the 4 minus t squared. Okay, so that's a u substitution. You could totally do it. So because between 0 and 2, it's this function, this top function. But you're not going to get problems like this on the 2020 test because it's an accumulation type of problem. It's an adding up type of problem where you integrate, and that is not going to be on the 2020 test. All the other parts could be, though, so we'll go through those. Part B says at time t equals 3, is Chloe's speed increasing or decreasing, and give a reason for your answer. What we want to figure out is what's the velocity and what's the acceleration. If the velocity and acceleration have the same sign, the speed is increasing. If they're opposite signs, one negative, one positive, then the speed is decreasing. So we can get the velocity at 3 simply by plugging into the second equation, because that's where 3 lies. So it's 12 minus 3 times 3 minus 3 squared. So that's 12 minus 9, which is 3, minus 9 again, negative 6. Now we're going to have to get a of t, and we get that by taking the derivative of the velocity. So that's going to be take the derivative of 12 minus 3t minus t squared. So that's minus 3 minus 2t. So a of 3, we would just plug in negative 3 minus 2 times 3. That's negative 9. So they have the same sign, both the negative. So our reason is the speed, our answer is increasing because velocity and acceleration. Don't forget to write these reasons on your test. Have the same sign. You've worked a lot of these. This is from your physics, but we've also touched. All right, even though they're both negative, that just means it's speeding up in the negative direction. All right, I'm going to erase part of the board here, so pause if you need to. And we'll look at part C on the next page. Okay, part C says, is there a time between 0 and 4 where Brandon's acceleration is equal to 2.5 miles per hour? Justify your answer. Okay, so we're going to be using the table here, and this is going to be a mean value theorem. Okay, so if we take the average slope, okay, and anywhere in these numbers, if the average slope, the slope of the secant line, is equal to 2.5, then we know that the slope of the tangent line, which is the acceleration, the derivative, is also going to be 2.5. So the easiest one to test first is just the two endpoints. Okay, so again, we're using Brandon's table here, the table up at the top, part C. The secant slope is going to be 11 minus 1 over 4 minus 0. That's going to be 10 over 4, which is 2.5. And we are in miles per hour. Let's see, miles per hour squared, right? So, is there a time? The answer is yes, because according to the mean value theorem, this one just keeps coming up, there is a time t where the slope of the tangent line must equal the slope of the secant line on a continuous and differentiable function. All right, so the key thing is mean value theorem. Show the slope. It's a lot of writing, but you'll have time to write that out. Okay, part D. I probably have room to fit it down here, but I'm going to go ahead and erase this. So pause the video if you need to. Okay, part D says, is there a time t between 0 and 2 at which Brandon's velocity is equal to Chloe's velocity? Okay, so we just kind of want to see, do these lines or curves, do they cross anywhere between 0 and 2? Okay, so let's look at get Chloe's velocity at 0. So c of 0 is going to be 0. So just if you plug in te to the 4 minus t squared, you're going to have a 0. So Chloe's velocity. Let's look at Brandon's velocity at 0. That's straight from the table. All right, and at 0, it's 1. So b of 0 is greater than c of 0. Now let's look at 2. c of 2, if you plug it into te to the 4 minus t squared, you're going to get 2 times e to the 0, so that would be 2. And just look at the table. b of 2 is equal to 1.5. So in this case, b of 2 is less than c of 2. So somewhere, you know, in this case, they must cross. Right? If b of 0 is bigger than c of 0, so basically what you're looking at, you know, is something like here's b and here's c going up. So somewhere they must cross. So the answer is the intermediate value theorem states that b of t must equal c of t for some value. Sorry, I made the camera shake. Between 0 and 2. All right, and your explanation is up here. B of 0 is greater than C of 0, B of 2 is less than C of 2. So hopefully that would do the trick. You definitely going to have to use the intermediate value theorem in your answer. So that's it for number 5, a pretty short one, but especially parts B, C, and D all could be asked. So a video worth watching and some notes worth writing, and I will talk to you next video.